first here. This is on page 413. So, what do you notice is the same on number 7? I don't ignore my line. That was from I thought I was going to get further the other day. Here, we'll just go like this. Okay, so what do you notice on number 7? The bases are already the same. This would be the easier version of the problem because I don't have to do anything to the bases. I could just skip up into the exponents. And I know that this exponent, negative 2a, must be equal to this exponent, 2 minus 3a. Everyone found page 413? Now I'm just solving this algebraically with my skills for algebra 1. How do I get all the a's on one side of the equation? Add the 3a to the other side. So I get a equals, add up a. And I have finished that problem, I guess. That was pretty short and sweet, but you've got to know how to go from here to here and set up the problem you're actually solving, right? Okay, so we did number 7 together. So I wanted to skip down in a minute once you have finished copying that to problem number 11. Did I say 11 before? Yes, 11. Could I just slide that down? I can't really because then I lose my stuff on the page. Negative 2a, 2 minus 3a, add 3a. A equals 2. There we go. So on number 11, I do not see the same base on both sides of the equation. One has a 36 and one has a 1/6. So what can I do? What power family do they both belong to? You're picking an integer between 2 and 9, really. So they both belong to the power 6 family. So I have to make a change on both of them to make them both 6s. 36 is 6 to what power? 6 squared, right? 6 times 6 is 36. So it is, I'm going to rewrite 36 as 6 squared. But then I still have this 3x that's hanging outside that parentheses. And 2 times 3x is 6x. So on the left-hand side, I change this to 6 squared, multiply my exponents. Now I have 6 to the 6x. Are you with me on that? How can I rewrite 1/6? That's 6 to what power? If my base is 6, how do I get to 1/6? Someone out there knows this. How do I take a reciprocal of a number? What's the exponent that does that? Someone knows this. How do I take a reciprocal of a number? How do I flip to the other side of that fraction bar? Come on. Make the exponent negative. More than one of you knew that, didn't you? Isn't this 6 to the negative first power? Right? Isn't that the reciprocal of 6? I'm sorry, this is 6 to the negative first power. All right, so now I have the bases the same. What can I do? I ignore the bases now, and I go up here into this exponent. 6x must be equal to negative 1. How do I get x by itself? Divide by 6. So it's okay to let a fraction. I would just leave it as a fraction, negative 1/6. You don't even have to divide it on your calculator. Just leave it as a fraction, negative 1/6. But I think most people at least got done the first few. So let's see, number 8. Let's see, 2x plus 2 equals 3x. And when I subtract 2x from both sides, did you just x was 2? For number 8. Number 9. How many of you took the time to go to a base 5? Did you do base 5 or did you do base 25? I was just talking about this with someone. 625, if you could recognize it, that's actually 25 squared as kind of a shortcut, but we should get the same answer. Did you get that 3k? Let's see, k would be 2/3. Did some of you change it into a 5 though? Or did you go, okay, so if I changed it into a 5 instead, This would have been 5 squared 3k 5 to the 4th. Is that what it is? 5 to the 4th. So you said 6k equals 4. You still should have gotten 2/3. Maybe you wrote it as 4/6, but 4/6 and 2/3 means the same amount. Okay, I want you to take a look at 10 and 12 with me because these are situations we haven't really come across. I get negative 2n equals negative 3n, right? And my next step would be to get one of those to the other side. So it doesn't matter which one you chose, but I'm going to add 3n to this side to get n. This has now all canceled, and n is equal to 0. And that's an okay answer to get. N could be 0. If I plug it in, I would get 4 to the 0 power, which is 1, equals 4 to the 0 power, which is also 1. So it's okay for n to equal 0. All right, but on number 12, something different happens. 3n equals 3n. When you subtract 3n on both sides this time, you get nothing. You get a big goose egg on both sides. If you think back to substitution elimination, what happened when we ended with no variable, but we have a true statement? The answer is all real numbers. I could plug in the number 2 up here. I would get 5 to the 6, 5 to the 6. But I could plug in any number. I could plug in a 1. I could plug in a 1/2. It makes it true no matter what I plug in, because it's the exact same thing on both sides of the equation. If you got a false statement, it would be no solution. And there was one, I think, on the homework or some other practice that comes out to be no solution. Let's see. 14 is up. 2k equals 2. So all I would have to do is divide by 2, and I would get k equals 1 on that one. And then let's see, 13 took a little bit more work because you had to change this 1 over 243 into a base of 3, which is the same as 3 to the negative 5th power, we decided. So negative 3n plus 3 equals negative 5. Subtract 3 to the other side, I would get what? Negative 8. So 8/3. Did you get n would be positive 8/3 when I divide by negative 3? Negative divided by a negative is a positive. Then you must have added the 3 and gotten a negative 2 right here. But if you subtract 3, you get negative 8. See? Minus 3, but this should have come out to negative 8. And you're telling me you got negative 2 instead. This is where you made your mistake, I think. And what'd you get for your next line down? Negative 3n equals. Okay. All right, so that was kind of just a refresher from yesterday, but this is hard. We're doing a lot of difficult algebra. Take some practice. People that were here 2 days in a row, I think after doing that many problems, you're getting it down, right? Hopefully. Okay, the other thing I wanted to take a look at, it is over negative 3, but I have a negative 8 on top, and I have a negative 3 on the bottom. So the double negative makes it a positive 8/3. Does that make sense, kind of? Okay, the other page I wanted to look at was some application problems. Oops, I don't know why I wrote a W on this. Oh, maybe because Wednesday. Today's Wednesday. Now I know why I wrote a W. Okay, I'd like you to write at the top A times B C X because we looked at this a little bit on Monday, and I want you to write down on this page what does A do and what does B do in an equation. This is page 414. We're going to do a few applications before lunch. Can someone tell me what A value always is? I wrote the word Wednesday. I was wondering why I wrote a W there. What does A do? What does the B do? Have to know this. We looked at the graphs and we figured out A was always the what? The y-intercept. You can also call that the starting value. So A is the y-intercept for the starting value. We're getting top of page 414. All right, what does B tell you to do? That's our growth or decay factor, right? Am I doubling my money? Am I halving my population? What's happening to my value here? So we're going to see this on this page. When representing decay, something that's decreased over time, you don't want to write down that you lost 2%. Because if you lost 2%, you'd have to subtract it off and then subtract it off again. If I lose 2%, how much do I still have? You know when they say like your bone mass when you get older from osteoporosis is 1% of your bone mass per year, how much do you still have? How much bone mass do you have? What would your car still be worth? 98% is what you still have. Right? So on a test, what does 67% mean? That's how much you had of your points. What did you lose? You lost 23% or whatever of the value. Wait, 23? 33%? Did I say 67? So 33%? So on this whole page, your decay factor, we're going to start from 1. So Mo owns a business. He purchased a $75,000 dump truck, which depreciates 12% each year. How much is the truck worth after 1 year? So there's 2 ways to do this problem, the long way or the short way. The long way is you can take, you don't have to down yet, you could take 12% of $75,000. I can't do that in my head. 12% of $75,000. You don't have to write this down yet. That is $9,000. Is that what the truck is worth? Is the truck only worth $9,000? No. I just want to show you. You start a problem the wrong way, and your answer does not make sense. Would it make sense that after 1 year the dump truck's only worth $9,000? Oh, I forgot. I have to subtract that from $75,000 now. You still don't have to put this down because I'm going to show you the shortcut here. What is 75,000 minus 9,000? $66,000 is the end value. I had to do 2 calculations to get that answer. 12%, calculate my loss, subtract my loss. The shortcut is you can just say how much is my truck worth? Instead of how much did I lose, how much is it still worth? How much of its original value? If I lose 12%, I still have what percent of my value? I have 100% and I lose 12%. How much do I still have? 88%, right? So if I have 88%, you did all that?
Yeah, also the circuit 211, the one with the polynomials is not in there.
And you wanted it?
Yeah.
Okay. I might have pulled it out, but I'll look for it. Thanks. I could take 88% and multiply by 75,000. Actually, the calculation I want to write down. Yeah, I would write this one down. Because what is, try it on your calculator, what is 88% of $75,000? 0.88, because 88% is a decimal, is 0.88. Or else we have to do 100 or 85 to show you, that's the one I want you to write down. That's the shortcut. I don't want you guys doing a lot of extra calculations. If we're taking 88%, you don't know what of means in mathematics? It means multiply. If you have 2% of a number, if you have half of a number, do you have a calculator? This is not a good one.
When you get a second, just like it doesn't have to be now. Can you see if I turned in homeworks 1, 2, and 3?
Sure.
Thought I did, but
I
I
can't read.
can't
Please give that to me. Did everyone get that it was the same answer? $66,000. So which one's easier? This one's easier. You just gotta remember to do it. I don't see 12% anywhere in this calculation, right? 12% loss became an 88% retention rate. So write an exponential function. X years appreciating. So after this problem at the top, what is my starting what is the growth or decay factor, and then X represents the number of years. You can get this example. You can do every single example we're doing after this. What? What did I do backwards? Oh, well, this was just my calculation. Correct. My starting value, so my equation is going to be $75,000 times the growth or decay factor in this case, and I'm raising that to the X number of years. We just did it to the first power. How am I going to calculate how much it's worth after 5 years? Where does the 5 go? Plug it in for X and tell me the value of the truck after 5 years. This is what people do when they're calculating their tax deduction. They might say, over the 5 years, what's the value of the truck? You get to deduct that loss from your business expenses. You can either do it when you first buy the truck, or you can do it once each tax season. So people who own businesses with lots of machinery, like Coleman's, are very familiar with this. What is the tax write-off and depreciation for buying these new vehicles? So make sure you type in 0.88 times $75,000, doing it for 5 years. Oops. I did it backwards. 39,000. Is that what it comes out to? $39,579, and I'm going to round 89 cents would be the value of the dump truck. Anyone know how much it actually does cost to buy a dump truck? I think it's more than $75,000 now. You do? I don't know. Should look it up. I don't even know where you buy a dump truck. Where would you buy a dump truck? A dealer? Okay. Let's do another one. This is still decay, remember? Radioactive decay. It's a big problem. I don't know if you guys in your life have heard of Chernobyl, the big nuclear catastrophe in Chernobyl, right? Because there's nuclear waste. People got cancer from being in the same region as the nuclear waste, and it takes years, decades, hundreds of years, thousands of years to get rid of this nuclear material. I was thinking about this when we lost power last night. Remember our discussion? And well, one of my classes we were talking about if we lost, was that your this class? Someone did a project on if we lost power, then how long would it take for like the human race to just be gone? And you said because of the nuclear meltdown of power plants, it would take how long? A week? No way, really? We don't have emergency power generator stuff that could last for 24 hours? Wow. Okay, anyway, radioactive decay, it's kind of important. This radioactive substance decreases by 30%. How much does it retain? As soon as you read that it decreases, what I would do is I would write that it's retaining every year. If it's losing 30, how much is it keeping? 70. That way you see that number in the problem so that you're sure to use it when you do your calculation. Okay, starting mass is 200 grams. How much will it weigh after 1 year? How do I say that? 200. We're not driving. If you did it like the truck problem the long way, first you would multiply by 0.3 and then subtract it. But for the shortcut way, the shortcut way says I have 70% of the starting value. So I can just multiply by 70%, and that'll tell me how much is left. Yep. 140 grams is still there after 1 year. Write an exponential function to represent the mass after X years. How much will it weigh after 10 years? And when will it weigh less than 1 gram? Do you think you can try that part of the problem before we go to lunch for a couple minutes and see if we can get the right answer? I'm just going to pull my answer up so that we can finish before lunch. I would do y equals 200.7 to the x. And if I plug in 10, what did you get? 200 times 0.7 to the 10th. 5.6 grams is still left. Did we get the right answer? Now, you could guess and check. I like to put it in the y equals menu. 200 times 0.7 x, and I can just go to my table. This will be fine. I can just keep going in my table till my table hits less than 1 gram. Did you say 15 years? Did you just press and check? If you get to check, the other thing you can do is you can arrow up. Oh, I can't on this calculator. If I arrow up, I can grab the equation and then I'll put in 15 and show you that it gets less than 1. Arrow up and just change the amount. So it would be, so this is this one, and it was 15 years. Okay,